Okie dokie, we are going to graph a polynomial function right now. And the very first step to graphing a polynomial function is actually factoring the numerator and the denominator. Okay, because we have to actually look at what we're dealing with, so you're going to want to factor it. So the numerator actually becomes x plus 4 times x plus 1, and the denominator is going to become x minus 4 times an x plus 1. Now, we had to find several things, several items. So we have to look for zeros, and you take your zeros from the numerator. So my zeros, okay, I set each of those equal to 0. You know, x plus 4 equals 0, x plus 1 equals 0. So I'm going to have zeros at x equals a negative 4 and x equals a negative 1. Right? Because I literally just took each of those sets of parentheses, set them equal to 0. I don't have a lot of space on here, so I'm not actually going to write that out for you, but that's what I did. Okay, then the very next thing we had to do was vertical asymptotes. So when we do vertical asymptotes, did this whole screen just kind of move? I think it did. Oh goodness. All right, well, we'll figure out later. Our vertical asymptotes, okay, you take your denominator equal to 0. You go in order, guys. To find the roots of your function, you set your numerator equal to 0. To find your vertical asymptote, you set your denominator equal to 0. So x minus 4 equals 0 gives me, I've got a vertical asymptote at x equals 4, and I have a vertical asymptote at x equals negative 1. Uh-oh. Okay, I see that, and I'm kind of, well, actually when I factored it, I was already kind of on the lookout, because the next thing we have to look for is holes in the graph. Okay. Now, remember, holes in the graph are caused by anything that is canceled. So here, since I have the exact same thing in both parentheses, the x plus 1, that's going to reduce down to just a 1, or you guys can think of it as canceling it. And so basically, you have a hole in the graph at x equals negative 1. Now, remember, the holes in the graph kind of, overpower everything else. Now, I did have a vertical asymptote, but I don't anymore, because I have a hole in the graph at negative 1. I did have a 0. I don't anymore because I have a hole in the graph at x equals negative 1. Okay. And last but not least, we got to look at, no, wait, there we go. Oh, on the search for colors. The next thing we have to look at is horizontal asymptotes. Okay, horizontal asymptotes. We have to stop and think, because there were 3 scenarios. Right? Horizontal asymptotes we get by looking at the degree of the numerator and the denominator. That's why I just circled the 2 exponents there. If the degree is the same, so in this case I have a 2 over a 2, right, and my x squared over x squared, then all I do is take my leading coefficient. So I have a horizontal asymptote at y equals basically a 1 over a 1, because remember you got a 1 here and a 1 there. So I will have a horizontal asymptote at y equals 1. The other 2 scenarios, okay, my mind just went blank. The other 2 scenarios, you have, if you have your, wait, like in number 2 on your worksheet, there we go, number 2 on your worksheet, your exponent in the numerator is bigger than your exponent in the denominator, then you have no horizontal asymptote. Okay, you have none. If you have a scenario where your exponent in your numerator is less than the exponent in the denominator, then you have a horizontal asymptote at y equals 0. I'm going to have to go double check that. It's been a while since I taught this, but I'm hoping that's right because I don't want to have to remake this video. So anyway, now that we have all the information that we need, we are going to start with the vertical asymptote and the horizontal asymptote. So I had a vertical asymptote at x equals 4, so I am going to go to x equals 4. And remember, the asymptotes are just dashed lines. Okay, so I have a vertical right there. I am going to have a horizontal at y equals 1. So I'm right there. Okay. And then I'm going to have a 0 at x equals negative 4. X equals negative 4 is my 0. Got to switch back to another color. So at negative 4, I am going to cross the graph right about there. Okay. And that's about the only other thing that I can do. Oh, yeah, that's about the only other thing I can do. All right, so what you do then is you look for, actually I would go to your graphing calculator, plug that in, and then you're just going to graph what you see. And when you do, you're basically going to graph something that looks like this, and we're going to have to go back and just double check and change it a little bit, and something that looks like this. Remember, your graph cannot actually cross the asymptote. And then I actually have to go back and do a nice little bit of erasing, which I'm sure that this eraser is going to take like a huge chunk out. Yeah, it took a huge chunk out of there. That's okay. Because I had a hole at -1, I have to go here and kind of remember how we actually kind of did that. We put a hole right there at -1. Beautifully drawn, Miss P. Beautifully drawn. So anyway, that covers everything we needed. We got our zeros from our numerator. We got our vertical asymptotes from our denominator. Remember, the holes are anything that are canceling. Our horizontal asymptote is 1 because our exponents are even, or are the same number, not necessarily even or odd, just the same number. And then you plug it into your calculator real quick after you graph your two asymptotes, and you get your general picture. Right? You do actually want to make sure that you've got any zeros, hence me going over to -4 and putting a 0 there. But that about covers it. Hope that one helped. Man, am I rusty on this. I think you should probably just go watch the other videos that I have up there because I'm sure they're much better.